Hello and welcome to the Unit 4 Section 2 video on the average rate of change and slope. So when we talk about average rate of change, what we're talking about is the change in that ratio. You remember the last section we talked about the tables where the x's change at a certain rate and the y's change at a certain rate, and if those rates are the same, or the ratio between those rates are the same, then you have a straight line. So the average rate of change just describes how the output variable changes with respect to the input variable. Okay, so we have our x's on one side of the ratio and our y's on the other side of our ratio. Okay, so rate of change is equal to our change in our y. So we're going to treat this as a fraction bar. So a change in y over the change in x. Okay, so let's talk about slope. Slope is an average rate of change for a straight line. Okay, so the slope is basically your average rate of change, but it's specifically for a straight line. You can only have slope with a straight line. So is the rate of the vertical change to the horizontal change between any 2 points. So your slope is, again, change in y over change in x. Now, here is a mathematical way to abbreviate that. We use the Greek letter delta. We say delta y over delta x. This delta that you see, I'm going to make a note here. Delta is just mathematical shorthand for change in. That way we don't have to write the words change in every single time. Change in y means we take our two y coordinates, y2 minus y1, and we divide it by our two x coordinates, x2 minus x1. So the difference between our y coordinates over the difference between our x coordinates. But make sure that you line up your coordinates vertically. And we're going to talk about that a little bit more here shortly. Slope and the average rate of change are exactly the same thing. Slope is just a special word that we use for the average rate of change for a straight line or a linear function. So let's talk about the four types of slope. You can have slope that is positive. You can have slope that is negative. And that is represented by an increasing and decreasing line respectively. So positive slope, increasing line from left to right. A negative slope is a decreasing line from left to right. Then you can have zero slope, which is indicated by a horizontal line, and a vertical line, we have slope that is undefined. Because our change in x is 0, and because our change in x is in the denominator or the bottom of our fraction, we're dividing by 0. And you cannot divide by 0. That is something that is not mathematically possible. So that's why we say it's undefined. By the way, since we're talking about functions here, linear functions, positive slope, negative slope, and zero slope are all linear functions. A vertical line is not a function because remember, you have multiple y's for the same x. So a vertical line is not a function. So to find the slope from a graph, our slope is rise over run. Our rise is our vertical change or our change in y. Our run is our horizontal change or our change in x. So let's talk about the procedures for finding the slope of a linear function. So the first thing you're going to do is make a triangle to connect 2 points on the line. You can only use vertical and horizontal lines to do this. Okay, so over here in this example, we're going to make a triangle going up 2 and going over 2. Okay, so we made our triangle here going up and over. We're going to count the boxes up or down. This is our rise. So here we have 2 boxes going up. Then we're going to count the number of boxes going left or right. And this is our run. And here we have 2 boxes going to the left, or I should say to the right. So we're going to simplify our fraction. Okay, so here we have 2 rise over run. In fact, let me write it that way. Our rise over run. This is our rise. This is our run. Our rise is 2. Our run is 2. And we simplify that fraction to 1. You must simplify your fraction. If you leave it as 2 over 2, I'm going to mark it wrong. It needs to be simplified. 2 divided by 2 is 1. All right, positive movements are going up and to the right. So in this case, we went up, so that's a positive 2. We went to the right, that's positive 2. Negative movements are down and left. So if we were to go down instead of up, it would have been negative 2. If we went left instead of right, that would have been negative 2. So let's do a few examples to kind of get our bearings on doing slope off of a graph. So for this first example, we're going to make our triangle. So we're going to go down and we're going to go over. So we went down 2, so that's going to be negative 2. And we went to the right 1, so that's positive 1. So we have rise over run. So our rise is negative 2. Our run is 1. So our slope is negative 2. For the next example, we have a horizontal line. And so when we have a horizontal line, our slope is simply going to be 0. For this one, let's look at it between the 2 points here. So we have let's draw our lines first. We have 1, 2, 3, 4, 5, 6, 7. So we're going down 7. Let's count that one more time to make sure. 1, 2, 3, 4, 5, 6, 7. So that's negative 7. And then we're going to go to the right. 1, 2, 3, 4, 5, 6, 7. This is also 7, but this is positive 7 because we went to the right. So you've got rise over run. So our rise is negative 7. Our run is positive 7. So we have a slope of negative 1. Now you can do a quick check on these. In this first graph, we have a decreasing line, which tells us that our slope should be negative, which it is. Same thing with this third one. We have a decreasing line, so our slope should be negative. So at the very least, you can tell if your sign is correct. All right, let's take a look at this next one. We have a vertical line, and for a vertical line, we know that the slope is undefined. Here, we're going down 1, 2, 3, 4. So that's going to be negative 4 over a run of 2. Negative 4 over 2 gives us negative 2. And then finally for this one, we go down 1, 2, 3, So we've got negative 3, and we go to the right, 1, 2, 3, 4, 5. Negative 3/5, that cannot be reduced, so that is our slope. All right, so we've talked a little bit about slope and how to find it on a graph. Coming up in the next section, we're going to find out how to determine slope using 2 points or also a table.